Okay, so one thing you need to know are the reciprocal functions. I always remember S goes with C, C goes with S. I'm sorry, I'm kind of hot and sweaty. It's a hot day here in Iowa. So sine goes with cosecant, cosine starts with C, goes with secant, and then tangent goes with cotangent. And these are just reciprocal, so you just flip. So if the sine spits out a ratio of 2/3, cosecant's going to be 3/2. It's just a reciprocal. So sometimes people write it like this, meaning that it is the reciprocal. Okay. So when we do problems, a lot of times we want all 6 of these. Okay. Another important thing to know is that tangent is SOHCAHTOA, but it's also sine divided by cosine. That can also give you the tangent. Okay, so those are kind of some important things to know. All right. The thing I usually tell my students when I'm face to face, so I'm telling you online, is that probably 80% of trig is either unit circle or bow tie. Okay, so if you think of 80% of trig, you're either looking at bow tie or something that is dealing with the unit circle. Okay, the other 20% might be I don't know, use a calculator, other type of problems, but or maybe converting degrees to radians, things like that. But 80%, this is huge. So if you know this, you know a lot of trig. Okay, and again, the bow tie is drawing the picture what's going on in the 4 quadrants, like on an XY axis. Okay. And really, when you do that, you're doing vectors. Okay. So if you have to take physics later and they talk about vectors, you are drawing like a vector going this way and this way. So in trig, we're okay with negative distances, and you might be like, you can't do that. Well, vectors have a magnitude, like a strength, but they also have a direction. So it's okay to have a negative vector because it says how it's moving. So that's kind of how I'm approaching trig. And then the unit circle obviously is, square root of 2/2, square root of 3/2, 1/2, those kind of things. Okay, 30, 60, 90 degrees, things like that. All right, so I have some problems here. All right, so say I tell you the sine of theta spits out this ratio. It's for sure in quadrant 3. And then I say find the 6 trig ratios. Okay. Is negative 2/3 on the unit circle? No. This is a bow tie problem. Okay. So where am I? I am in quadrant 1, 2, 3. So I'm going to draw a bow tie right there. Okay. Because I know I'm here. Sine is what? SOHCAHTOA. So if you're doing a bow tie, there's kind of 3 musketeers that go together. The bow tie, SOHCAHTOA, and Pythagorean theorem. Okay, those 3 always go together. Okay, so let's see. I want SOHCAHTOA. So this is opposite. This is my hypotenuse. So my hypotenuse has to be positive. So that's 3. Opposite is 2. And it's a negative 2 because you see how the vectors are going back and down. So even this side has to be negative. Okay, now sometimes when you do Pythagorean theorem, sometimes you add, sometimes when you do Pythagorean theorem, you subtract. But Pythagorean theorem is all about area, the area of a squared, b squared equals c squared. So the 2 legs are a or b, a negative 2 times a negative 2 is a positive 4. If you do that on a calculator, you need parentheses. Negative 2 times negative 2 is positive 4. This side, I do not know. That's one of my legs. Hypotenuse is always C. 3 times 3 is 9. There's no way to get a negative in the midst of Pythagorean theorem. Okay. This is a subtract kind because I know C and I want to solve for B. So this is a subtract kind. B squared equals 5. And then I'm going to square root. Now, as far as when you square root, you get 2 answers, positive or negative. But these are vectors. So I don't really, I got to look at my picture to decide. So this vector is going backwards. That's a negative direction. So negative square root of 5. So I'm going back and down. Okay. So sine, I want to find all of them. So I like to do sine, SOHCAHTOA, so tangent. And then I like to do the reciprocal functions next to them. So S with C, C with S, and tangent with cotangent. All right, I'm going to do my ratios first. I will make them pretty after the fact. Okay, and I'm going to cover this up just so you don't pay attention too much. All right, so let's look at these. Sine, I already know, -2/3. So the reciprocal is just going to be a -3/2. I'm just going to flip it right away. Cosine. All right, so katoa. So adjacent is -√5 over the hypotenuse 3. And I'm going to come over here and again, I'm going to do the reciprocal. I'm just going to flip it over. Tangent is SOHCAHTOA. So opposite over adjacent. So opposite over adjacent. And two negatives divided make a positive. And then I'm going to flip that. Okay, so that would be what? Positive square root of 5 over 2. All right. Now I'm going to make them pretty. These are okay. This one we usually rationalize the denominator. So I'm going to multiply the top and bottom by square root of 5, and I'm going to get 2 square root of 5. Square root of 25 is 5. So that's a better answer. This is pretty. This is not. Okay, rationalize your denominator. You get -3 square root of 5. Square root of 5 times square root of 5 is square root of 25, which is 5. So these are all nice and pretty now. So, right? And I don't know if Newton or my math lab will make you, rationalize the denominator or not. You'll have to figure that out. All right. Okay, let's look at the next problem. This will say something about you have an angle where the terminal side ends at -4,2. And then it's going to say find the 6 trig ratios. Okay, so if you graph this, this is just a point. So let's go and do this. We're going to go back 4. So 1, 2, 3, -4. And we're going to go up 2. So -4, 2. And we're just going to plot the point. Okay. Is that on the unit circle? No. It's not a square root of 2 over 2. It's not a half. It's not square root of 3 over 2. This has to be a bow tie. So when it's bow tie, you know you're going to do SOHCAHTOA and Pythagorean theorem. Those are going to be the 3 musketeers that you are going to do. So first of all, you need to draw your bow tie. Well, remember, bow ties, how they look, right? They always have that point there. They come out, right? Because again, a bow tie looks like that. All right. So we only want one of the 4. All right. So theta is right there. You're always there. And again, that's a reference angle if anybody cares. But all right. So I'm going back 4. Notice I'm going up 2. So my vector is going back 4, direction and magnitude up 2. All right. I think I might sneeze. Excuse me. All right. So now I have to do Pythagorean theorem. Again, Pythagorean theorem, sometimes you add, sometimes you subtract. This time I want to find C. So I'm going to add these to get C because the formula for Pythagorean theorem is a squared plus b squared equals a c squared. I know these two. Now again, when you square them, you cannot get negatives because this formula is all about area. Cannot have that. No negatives. So 2 times 2 is 4. A -4 times a -4 is at positive 16. Again, if you're going to do that in a calculator, make sure you have parentheses. Add those, you get 20. And then I'm going to square it. Now, to rationalize that, we're going to take out a square root that's pretty. So 4 comes out, the 5 doesn't. I get 2 radical 5. And again, hypotenuse always has to be positive, can never be negative. Okay, same thing. What are they going to ask? They're going to ask for sine, cosine, tangent, and they're probably going to ask for all 6 trig ratios. So S goes with C, which is cosecant. C goes with S, which is secant, and tangent goes with cotangent. Okay. All right. So let me look at my triangle. I'm going to scooch that up, and then I'm going to cover that up so it doesn't bother you. All right. So all you do now is the SOHCAHTOA part, right? I guess I didn't finish my TOA there. I don't know what happened. All right. So sine is what? Sine is opposite, SOHCAHTOA, opposite over hypotenuse. And I am going to flip it or do the reciprocal. And I notice those cancel, right? And these cancel over here, but we'll make it pretty in a little bit. All right, cosine, SOHCAHTOA, adjacent over hypotenuse. So -4 over what? 2 square root of 5. And again, I'm going to reciprocate it before I do too much. And I'll deal with the 2 in common there too in a little bit. I probably should have waited there. Tangent is what? Opposite over adjacent. So 2 over -4, and again, flip that -4 over 2. Okay, so now I'm going to make them pretty. Well, this one, we never leave negatives in the denominator, and I'm going to reduce that. So that's a -2 halves. and 2 goes into 4. This is a negative 2. Okay, those are nice. Let's look at this guy. Okay, so when I cancel the 2's, I get a 1, and I'm going to rationalize this. Square root of 5 on top, square root of 5 on bottom. So that's square root of 5. 5 times 5 is 25, gives you that. Over here, I just canceled the 2, so square root of 5 is pretty. Over here, let's see, 2 goes in there once, 2 goes in there twice. And then I'm going to rationalize. Square root of 5 on top, square root of 5 on bottom. So what is that? Negative 2 square root of 5 all over 5. And you can't cancel things under the radical with outside. Outside numbers can reduce with outside, radicals with radicals. All right, so this is an outside number. 2 goes in there once, 2 goes in there twice. And I get negative out front, square root of 5 over 2. And there we go. Okay, so again, how do I know they're bow ties? Because they either give me a point that's not on the unit circle, so I graph it and make a bow tie, or they give me a ratio that is not on the unit circle. All right, so what maybe would be on the unit circle? Well, let's look at this. All right, they tell me that the ratio is square root of 2 over 2, all right, and that I'm in quadrant 4. Okay, this is on the unit circle. So, I mean, you could draw a bow tie because the unit circle really is a bow tie, but I am right, what? That would be quadrant 2, right? Quadrant 1, quadrant 2. That would have a square root of 2, negative. This would have it 2. So would this, so would this. But some of them are positive, some are negative, right? Cosine is positive here, and positive sign, cosine is positive, negative sign. So they tell me I am not in any of these quadrants. So in the unit circle, I'm right here. What is that? It's at a 45, right? Square root of 2 over 2. I'm going to the right and I'm going down. Do you see how that's still, there is a bow tie, right? It's just we don't always draw it on the unit circle because we just know it, right? So square root of 2 over 2 and there. All right. Now, say they ask me, they could ask me lots of things. They could say, find the sine of theta. So they're still asking me to find a ratio. They could ask me to find the tangent of theta. All right, well, sine would be what? You don't be doing opposite over j. No, you know it. Here's your cosine, that's your sine. Negative square root of 2 over 2. What's your tangent? Again, don't be labeling sides. Tangent is sine divided by cosine. A number divided by the exact same thing as 1, but there's a negative, so that is a negative 1, okay? Here, tangent is square root of 3, and it's in quadrant 1, okay? So you should know that tangents are either 1 or negative 1 on the 45s, and they're square root of 3's or negative square root of 3's or square root of 3 over 3's on the others, and I'll show you this. So again, I recognize that this is on the unit circle. Now my problem is I don't know where I'm at, so we got to figure that out. This one's over 0.9, so about square root of 3 over 2.5, and this is a half square root of 3 over 2. All right. And again, yes, there are triangles here. These are all bow ties on the unit circle, but again, we kind of call it the unit circle. But all right, tangent is sine divided by cosine. I'm going to do this one. Sine, the way you divide is you multiply by the reciprocal. These cancel, rationalize, and rationalize. So this guy has a tangent of square root of 3 over 3. And if you want to write that on your unit circle cheat sheet, I would, okay, just so you know. So this guy's square root of 3 over 3. This guy's going to be square root of 3, and I can show you. Sine divided by cosine, you're going to multiply by the reciprocal. You get tangent is square root of 3. So I know I am up here at this point, okay? This is where I'm at, okay? So they could ask you, okay, what's the cosine at that place? Well, cosine is a half. They could ask me sine at that place. Well, what's sine? Square root of 3 over 2. If they wanted to, they could even ask you what's theta, right? What's the angle? Well, that's a 60-degree angle, or it's pi over 3, whichever you're in, radians or in degrees. So again, if it's something that is on the unit circle, you're not necessarily going to draw a bow tie. I mean, you could. I could draw a bow tie here and label this a half, square root of 3 over 2, and the hypotenuse is 1, because the unit circle, it's always 1. But again, that seems kind of silly, right? So it's either on the bow tie, or you draw a bow tie, or unit circle. And again, 80% of the time, okay? So again, how do you know? Well, I would say if someone says the terminal side is at 3, 5, right? Find the 6 trig identities, that's bow tie. If someone says, hey, tangent of theta is 4, and you're in this quadrant, that's bow tie. Now stick a 1 under it so you can see the opposite over adjacent, but it's a